All right, we might as well start. There is 8 of us in here, so I know Adam couldn't be here. Amy, I'm not sure why she's here, and then I think we're missing one more. So statics, right? Everyone in the right spot? Study of forces. All right, so this is the book. Here, I'll pop. Oh, first of all, before I get started, I'm going to record all lectures. So I made that clear to most folks that asked about it. Educationally, I think it's the best if you're here because that exchange is good and we go over homework, we answer questions, those kind of things. But I get it. If you can't be here, that's fine. I'll record them all. I'll put them all up. They'll be available if you miss a class. Friday will be online always, unless we have a lab, and I'll try to give you lots of notice. So I'll try to keep the calendar current. I don't know why it keeps popping everything on. It probably won't do that to you, just to me. But if we have a Friday lab where like we build a mobile or we work with the truss system, we have a couple of different labs I really like to do, a friction lab. We might pop those on Friday, just depending on how well the content's going. Okay. So I'm recording this. It'll be available. I'll put it in Blackboard on the day that it was recorded. So the flow of Blackboard is just week by week. I try to keep it really simple. This is not really an online class, but I'll keep it current. I'll keep the days and the weeks going. And then, so if you miss a day, you would go to Monday, the 9th and look for the lecture, right? We'll track everything with the calendar. It's really annoying that it's doing that. It won't do that to you, I'm pretty sure. So like homework sets are here. We have one today, right? Those are always due the next class period. So Mondays would be due by Wednesday morning, right? If you come and you have it physically in front of you, that's the perfect setup. It's done, it's in front of you. I go over the homework immediately. You can keep it in front of you for that process of going over it. That is the way homework becomes educationally valuable. Like that's where you'll get something out of it. If you mucked it up, that's fine. Just take a different color device, you know, a red pen or a green pen or just something different and write on it as I go through it. Because you want to correct your own mistakes as you go through the homework. Doesn't do any good to do homework, not get any feedback or not get the problems corrected. You'll just repeat those in the quizzes and the exams. So first part of class typically is going over homework. That can take 30, 45 minutes. It can take a long time. These problems get long and they get confusing. So we want to clear all that up before we go into new content. So that's why I think it's 2 hours, right? 8 to 9:50 or something. No way I'm going to talk for that long. No way. Okay. So we go over the homework. That won't happen today. So today's kind of short. We get that done. We submit that. Then I do new content and then we might do some practice problems. That's kind of how it flows. So don't think you got to show up at 8, like fully listening to me for 2 hours. That's not going to happen. Sometimes I have homework problems on Friday also, like there probably will be this week because I really like to get chapter 1 and done this week. Then that'll be due the next time we meet. There's no school on the 16th. Campus is closed. I think it's MLK Day. So then that would just come in the following. So since we're going to kind of operate a little bit online, I'm going to keep a submission area going for the homework sets. So if you don't come to class, like Wednesday, let's say you're not coming, you have to work, you got the homework done, you're going to have to submit that to Blackboard still by Wednesday morning. Does that make sense? So the little software that we've used is Cam Scanner. It's super nice and it's free. So if you don't have this software on your phone, you should get it because I use it all the time. If you've had me before, then you already know about it. Oops, I was going to show you what the logo looked like. So the logo looks like that guy right there. It's CS Cam Scanner. What it does, if you've not used it, is you just open it, hit the little camera thing, And you can't see what I'm doing, but I'll take a picture of the book, took a picture of the book, and it does something like that. It rotated at that time, but it does a great job taking a picture of your homework and turning it into a PDF. Then you can just submit it to Blackboard. That makes sense? If you're coming, then you don't have to do that. So it's going to be a little weird. You're going to see like, oh, one person submitted to Blackboard. Well, that's because everyone else came to class and just turned it in. Okay. So either way, if that ever gets weird and doesn't work for you, you can always email it to me, like just send it. Since we're going to operate this way, I don't really need to know if you're not going to be here. I mean, it's nice if I know, because I would wait if you were coming, you know, I'd wait till 8:05 or something to start. But you don't have to let me know. I'm just gonna, if it's just me and Ray, I'll just lecture to Ray, and that'll be weird, but we'll just do it. We've done it before. So like I said, there's 8 of us in here. Questions so far? Got to get it online. You can get it through the bookstore, but I would go for like Amazon or something like that, try to find it. So I think they said it's been discontinued, but there was quite a few used versions of it out there. So for the first, I don't want to screw the share up. I do that often, so I'm going to reshare. There we go. For the first homework set, today's, I think I don't normally put the homework set in the folder. It's going to be just all calendar driven. So go to the calendar to see the homework sets. But today I did because I scanned the book. So you can see the homework sets for tonight. And I'll keep doing that until I kind of know you all have the book. So I'll just put a copy of it up. So if you click on that, you're supposed to get the, well, I'm supposed to say get the book, but yeah, that would work. I would just have to keep scanning it. Or you can just take pictures of it as we go through. So that's probably going to work until like chapter 4. And then, I mean, the preferred system is you read a little out of the book, right? You get some material that way. Hopefully you get confused that way. An ebook. Oh, that's not bad. Okay, that's pretty good. 2 classes too. So we're going to do strengths out of it also. So that's nice. So bookstore sounds like the best route. For the content that's confusing, for the content that's like not going perfectly, and there will be some of that, you should read out of the book. You should attempt the homework, and then you should come to class. And then through those 3 systems of getting this content, you'll be fine. Like you'll get it. But if you're just doing one of the 3, then sometimes it gets complicated. Chapter 1's nothing, should be pretty easy for us if we've had trigonometry before. Chapter 2 is just the beginning parts of forces. And again, a lot of trigonometry, because that's how we deal with forces. But then 3 and 4 gets fairly complicated with equilibrium. So we will definitely spend some time on some content. So. Huh? We're going to do 10 chapters. So some of those we fly through pretty quick, and it's okay if we don't get to 10, like if we just get through 9. And I have the luxury of the follow-up course in the same book. So if like we got through 8, then that just jams us up more for strengths. So I will go quick, but I won't go so quick that I lose you. Like I'll stop if I need to. Like when we get to trusses, that's a solid 2 weeks in chapter 5. So I've paced this course a lot. I kind of know where we will slow down and where we can speed up. The thing is, like, if trigonometry is just like not second nature to you, I'm going to just kind of blow through it this week. Then you got to do some extra stuff, like to tune yourself in quickly, because then we're going to just lean on trigonometry all term. And I'm going to just like think you know it, right? So if you don't, like if you haven't had it in a while and it's super rusty, then I'm here at 7. You can come in early. It's kind of how I roll. And I can help you with some of it. And then after this class, I have an office hour. I'm just going to hang out right here until the next class at 11. So I guess just be super honest with yourself. Like, oh my God, sine, cosine, tangent. I had that once when I was 6 or something, right? But if it's there, then yeah, you're good. Okay, so that's that. Back to Blackboard a little bit. I left some things because you did, in Blackboard, essentially you just do a course copy, bring in all the content from the last time you taught it. Last time I taught it was online. So I'm going to leave some of those old videos there. You don't have to watch them. They're just going to be there. I will try to label them old. So like today's, it'll be this date, this lecture, and I'll probably put winter 23, right? So you can like fully identify today's. But like these old ones, I'll try to write old, right? Old video. And I'll leave them, right? So you can look at them if you want. If not, let's just skip it. We have mandatory attendance. So I have to take attendance. And the way I like to do that is just to make you post something up in Blackboard. So here under work submission, there's a mandatory attendance thing. You have all week to do it until the 12th. EOD means end of day. SOC would be start of class. That's kind of how I just note it. But go in here, post something up. That means you were here. That means also that you can get into Blackboard and function. Those are 2 super important things. So all week to do it, but don't forget to do it. It's worth 10 points. Mandatory attendance. The syllabus is in here for your review. I don't go over it. I don't need to, but it's here. A lot of times students want to know just the details, which is grading. So the grading scheme is here. It's weighted grading. So hopefully you've had that before. If not, I can walk you through it, but essentially you have 100 percentage points. You can think of those as just 100 points that you can collect in the term. 20 of the points are quizzes. 30 of the points are the exams. 30% or 30 points is the final. Okay. So homework, 20 points. So each of those are your categories that create your grade. And then I'm not a hardliner on this. I'll just be honest. Never been a hardliner on that. I don't, but I got the final in there for you. So I'd like to get through chapter 4 before we do the midterm. So my guess it would be the 5th week. So I have 2 midterms, but the first midterm is at midterm. And then the second midterm is like late in the term, and that should be just a good prep for the final. So second midterm is probably week 8, and then the final is week 11. That makes sense? I can get it in there. I like to get in early, especially since I'm kind of making attendance optional. You got to know when to be here for that one. So yeah, so on the hard line this, so here's my philosophy is if you get an 88, that's like a B+ or an A-, something like that, but we don't do that at this campus. So for me, an 88 is an A if I think you've worked hard, and it's a B if I think like you could have got an A so easy, you just you didn't work, right? So kind of like that's where it becomes a little, I don't know, subjective. Like I know how hard you're working, how hard you're not working. So if you just give it a solid effort, then that'll rise those borderline grades. Nothing pisses me off more is when my kids get an 89 and they give them a B. I'm like, what's the point of that? Like, it's a power play. Anyway, calendar. Let's look at that. Yeah. Which class would you like to look at? I'd like to look at the class I'm in. Class do you want to look at? All right. So yeah, I have 2 weeks going right now. Let's see here. Yeah, our final's Monday, the 20th. Oh, still has 2 classes, even though they're not checked. That's weird. Weird. Yeah, I'll get the midterm in there. I think the quizzes are in. Yeah, quiz 1 and quiz 2 are in. Oh boy. Calendar things tripping me. I think that's us. Yeah, quiz 1, quiz 2. Fridays will be quiz day. So it'll be exactly the homework. So not exactly, but like if we're doing right triangle trig, your quiz will be on right triangle trigonometry. We'll do right and non-right this week. So it'll be online. It'll be available all day on Friday, all day. So you can do it, submit it. It gets submitted in this area where it says quiz and exams. That's actually the journal. I don't know if you know Blackboard, there's discussion area. That's this. I just renamed them. And then there's the journal, and the journal's private. So when you go to submit your quiz, you won't see anyone else's quiz. So don't like go, oh, nobody else is doing the quiz. They're doing it. You just can't see it. So again, it'll become available on Friday. You can work it, take a picture with Cam Scanner, and then submit it. And it is definitely the honesty system because, yep, you all could be sitting together doing it, but I'm guessing you're probably not going to do that. I think that's pretty much Blackboard and how the course is going to flow. We will meet Monday, we'll meet Wednesday, Friday will be online. I think the quiz is already there. Yeah, I already put it there just to show it to you. So a lot of times it's just a problem out of the book. Obviously, one we haven't done. I'll say do number 6, submit it, that's your quiz. Sometimes I get creative and make my own. So look for that. What else? Any questions so far? No, all my online stuff is asynchronous, not synchronous. So I'm going to record it. You have to watch it on Friday. What I do often on Friday is I have you do something from my lecture on Friday, because if I'm going to make it, I really want you to watch it. And then if you watch it, I really want you to get some point value out of it, because point values are why you're here. That's my motivation, is to give you points, right? Or to take them away. I don't want to do that. No class on Friday. Do not have to come. Be online lecture. And that'll be like, and then there will be Fridays where I don't do one. Like, we don't need it this week. But if I feel like we're just not keeping up, we need to like bump a little bit ahead. Or I want you to like do a little something in prep for Monday. That's when I'll use the online lecture. So I'll produce one this week. You'll kind of see what it is. They're short. I don't like to lecture longer than about 15 minutes because your attention span is about 12. That's what they say, which is, I think, true. Like, that's kind of mine when I'm sitting listening to someone talk. So they're usually short, very specific on a topic, and then make you do something and submit it. Okay, does that answer your question about Fridays? Yeah, cool. Email is perfect. Email in here comes straight to my email through Mount Hood. So it'll show in here, but it'll also show everywhere I get my email, which I get everywhere. So if you have questions on anything, send me an email, ask it. A lot of times, like if you have a homework question, ask it, because what I can do with Zoom, now that we're Zoom pros, is I can just make a recording just like that, rather than trying to type, oh no, you should be using cosine or sine. I don't do that. I just like, oh, I'll just make a little recording, then I can make a drawing, and I can say, do this, try this, something like that. So I can give you hints that way. Don't hesitate to do that. Cam Scanner, I don't know where that came from. Oh, I opened it. All right. I think that's good. Let's talk a little bit about trigonometry. Maybe the book. Stop share, start share. Oh, I do want to do the homework format, but I was going to do that while I did a little trigonometry. So this is the book. 2 terms worth, so get the thing. My opinion is through my bachelor's degree and then through my master's degree, this class, statics and strength of materials, are the 2 fundamental classes if you are a mechanical engineer and probably even a civil that you will use throughout your career. Like this is the stuff you will use over and over and over. I use this stuff over and over and over. Now I don't do super I mean, I'm not out there designing bridges and stuff, but I do a lot of beam analysis. I do a lot of span work. I do a lot of strength work. And these are the 2 classes, statics and strengths. Like you can make a living off of these 2 classes. So I really like emphasize how important it is and that you should actually get a resource, whatever resource you learn with, which is this one, and keep it. This would be not a sell back thing. This would be a keep thing. All right. Let's talk about the homework format just a little. I am a stickler on it, so you got to follow it or you lose points, which is, again, my way to motivate you, right? But this kind of thing, we do a lot of pencil and paper work still. Everyone thinks it's all computer-based. It's not. When we do calcs, a lot of times that's hand calcs. There is all kinds of calc softwares out there. There's Struct Calc and everything else. But when your calcs come back to you from somebody who's reviewing them, it's all handwork that's coming back to you. You may then put it back into Struct Calc and get some more fancy looking calculations. But there's a lot of folks that still do it by hand, and we do a lot of handwork. So our handwork's got to be engineerish, I like to say. Doesn't have to be gorgeous, but it's got to be engineerish, which is caps. We write in caps. And I know there's a lowercase c already, but that's just so I can identify it from a larger case c. So sometimes we need lowercase and uppercase just to use those variables. Variables are a specific thing, right? We have a lot of variables that are Greek, alpha. We have a lot of variables that are just capitals, big S for stress, little s for shear, all those kind of things, right? But overall, in general, when we just write, it's caps. So like when I write my name, it's caps, and it's decent lettering. Doesn't have to be perfect, it's just decent. We need to be able to tell the difference between a 9 and a 7. I always use 9 and 7 because I screwed that one up like my very first month of work as an engineer. I misread my 9 as a 7 because when I go really fast, it looks like that. So that was a 9 that I just drew. Well, 2 days later, I read it as a 7. And that threw everything off in a big way from what I was calculating. And I was calculating a dirt pile, a pile of dirt that we had to put into dump trucks. So I came up with about, I don't know, a couple 100 yards worth of dirt that we didn't have. So the dump trucks just kept coming after the dirt was long gone because I misread my 7 and my 9. So just go slow, set it. It's all about going slow. For me, it's all about going slow. Just set it up nice and slow. If you're going to use a graphic, which you should on everything, you should use a graphic, then use a straight edge. That's it. Everything else is fine, but just make a decent graphic and set your homework up as if somebody's going to review it, because that's what's going to happen. When you do stuff, somebody else is going to look at it. We need your name, we need the class number, and the date. Those are important. So then I know when you did it and it's on time or it's late, right? If it's multiple pages, it doesn't hurt to have an area that says, 1 of 6. You can write 1 of 6, you can write 1/6. That kind of looks like a date. We won't have 6 pages, but we might have 1 of 2. Then I know, oh, there's a second one, right? But each homework should have your name on it, and it should have the homework set right there. And that's, so when it comes in late, I can get it in the correct pile. So a lot of this is for me because I'm going to review your work. But when you do your work, when you get out there, somebody's going to review it. So if it's just nice and pretty, I have found that I get a lot further with people. Like things go better if my work is nice and clean. When I submit to the county, like I make it really pro when I submit and they look at it and they're like, oh, an engineer produced this, we're good, right? If I just turn in crap, they're going to be like, oh, a farmer produced this. We got to like really analyze this now. So, I mean, I use AutoCAD, I use Excel, I use all the tools to make it gorgeous, but sometimes I do hand calcs. And if you can make a hand calc look gorgeous, they're like super impressed with that. Of course, that's what you want. So that's what I want. We need a problem statement. It can be short. You do not have to write the problem statement from the book. Some of these are longer problem statements. I don't need it word for word from the book. I just need to know what you're trying to find. Like what's the point of this problem, right? This one says find C and A. A is this angle, C is the hypotenuse. So if it says that, it should be on the graphic. So I can look at this and go, oh, we're looking for that and that. This might sound really simple, but so many things come to me outside of education come to me and they're like, they're finding this thing. And then I go to the drawing and the thing is not on the drawing. Like, what are you talking about? And then it's like 4 phone calls to figure it out where they just were a little more detailed, we'd be good. So now that we got all that, I'll get my pile of dirt out of here. So we have a problem statement, we have a graphic. Then we just need the solution. You don't have to title this stuff. Like if you look at the homework format I put on Blackboard, everything's titled like problem statement, and then there is the problem statement. Given, and then there's all the given stuff. You don't have to do that. Just get it down. It's kind of a top to bottom flow, and then it's going to flow left to right for the solution. So I might, if I'm looking for angle A, first of all, what kind of a triangle is this? Yeah, I'll help you. It's right triangle, right? Right triangle means the fan is super loud and I'm deaf. So yeah, 90-degree angle, simple stuff, right triangle stuff, right? So what do we know about triangles and their interior angles? They all add up to 180. So if we sum, that's my summation, the angles, we should get 180 degrees. Is that true in non-right triangles also? Yeah, so that works with all triangles. Does everything work with all triangles? No. Certain things for right triangles. So if I want angle A, I can do what? Add up all the angles. Know that all those need to add up to what? 180, right? So how do you show me that? You, on the simple stuff, if you think I can figure it out, then it's fine, right? I don't just want angle A equals and the solution. I would like to know where you got it, right? So I might write something like 180 degrees minus 28 degrees minus 90 degrees equals angle A. Something like that, right? And there's a few other ways you could write it. That's fine. It'd be great to see like how you're getting stuff, and then angle A. Straight to the solution is fine. Okay. My recommendation is don't do anything in your head, not even like 6 + 9. Nothing. Verify it in your head if you want. Okay, 6 + 9, I think is 15, right? But then I would literally go and I'd calculate it. So that's just me. I can make mistakes if I do it in my head. So you need a calculator. You can use your phone. I actually have a perfect simulation of this calculator on my phone. So when I forget this, I can still operate. TI, HP, completely up to you. Whatever you use in your math class is what you should have. Because they, I think, demonstrate with it on the overhead, right? And they do higher level functions on their calculators. You need that calculator. I'm an HP guy, so that's what I use, which is, it runs reverse Polish, which is what I love for long equations. But it'll run TI systems also, but so get whatever works for you. But you're going to need it, and it's, you know, it needs to be scientific. Other than that, it does not need to be high powered. You don't have to get a $200 calculator. Most calculators do scientific stuff now: sine, cosine, tangent, and then the inverses of those, square root, that kind of stuff. All right. So when we work stuff in class, I like us all to work it. So like this right here, I'd like to know what that number is, and I'll calculate it just because it's like what I want to do, but you all should calculate it. And then we all should verify that number. Like, what'd you get? Everyone should be able to pop that out. That's just good practice with your calculator. When we get into longer equations, it's remarkable how we'll get 8 different numbers from calculating the same equation. Like, it's not always easy just to do it. This stuff's easy, but all right. So what'd you get? 62? 62 degrees. All right, let's talk about accuracy and precision. Not significant digits. Significant digits is really cool in math class, but engineering doesn't use significant digits. In other words, if it starts with a 0, that doesn't matter to us. Like, if you read the sig fig conversation in the book, it's crazy. I mean, it literally says if it starts with this number, it's this accurate. If it starts with that number, it's this accurate. And I'm like, how can that even be? That's nuts, right? Like, if I measure it with this, how accurate is it? Yeah, I think I can measure it to the 16th. I'd still probably say plus or minus something. Like, I'm not spot on. But to get to the 32nd, come on, no way. So that's great. If I measure it with this, how accurate is it? Thousands. Should be. Like, I should be able to get to 1,000. Sometimes I think I can get like in between, but not really. So that's what's important, is like how it was measured is how accurate it is. Not whether it starts with a 1 or a 0 or a 7. I don't know. So that doesn't really work in academia, but it does work in industry. That's how it works in industry, right? Somebody sends me a bunch of numbers. The first thing I ask is, how accurate is that? Like, did you guys survey this, or did you step it off? Sometimes they just stepped it off. I'm like, holy crap, that's not very accurate, right? So we need a system for that. And my system for it is just making an assumption about all the numbers that come to you in the book, right? That's all we really can do, because you're going to get numbers thrown at you in this book that you have no idea where they came from, and we have nobody to ask. So every number that we get is going to be to 2 places. Okay, so if you give a number 4, it's 4.00. Does that make sense? If you give an angle 70, it's 70.00. So then we know all numbers have the same accuracy of this 0.00. So then we can report that accuracy, because we can only report on paper as accurate as the information given. Does that make sense? If we don't know it, then we really can't report it. So this is really 28.00, 44.00, 10.00. You don't have to write the 0.00. That's an assumption we're just going to make. Is that fair? So that means this can go to what? 62.00 degrees. All right. And I would like to see that kind of accuracy in the solution. When you get the solution, it should be like I double underline and I point to it with an arrow. Usually my arrow comes from over here. So again, just being honest here, that's a helpful thing for me because then I can just look for your solution. And if your solution's right, I can kind of scan your work with my eyes and say, they got that. If your solution's wrong, then I can back up and look at what you did and figure out what you did wrong. Okay. So some kind of commitment to the solution would be great. Don't need, I think Amy uses multicolored pencils and flowers and stuff. Like you could do that. That's cool. I always like her graphics, but you don't have to. Just underline it, point to it with an arrow, something. How would we get this? What is this? What's that called? Hypotenuse, also side C, right? Sides are lowercase. Angles are uppercase. Okay. Sides are opposite their angles. So angle C, side C. Angle A, side A. That's just normal labeling. Again, why do it that way? Well, it's so we all do it the same way, kind of. It's helpful. Like when I get something from somebody else, if they've done it to like an engineering standard, I got it. If they've done it to like some company standard, which is not to an engineering standard, maybe, then I'm like, it just takes me a long time to get through stuff. So that's why these systems exist, so we can kind of look at each other's work. All right. Let's maybe before we go for C, let's get all of our tools for a right triangle. What are the tools? We have the angle thing, right? What else? Still didn't hear it. Yeah. Area of the triangle. Yeah, it's all right. It's all good. So areas is a property. What's the area of a triangle? That's so weird how people remember it. Like it's how you were taught, right? So for me, it's 1/2 base times the height. But if I said it in the wrong order, I'd be like confused. It's weird. But yeah, so that's a property of the triangle, but it doesn't help us find the pieces. What helps us find the pieces? Angle, sides. Angle, angle, side, side. What equations? Pythagorean theorem. What was that one? Notice they're all what? Lowercase, which means it deals with sides. Yep. So to run this, what do we have to know? Two sides. We have to either know A and B to get C, or we have to know B and C to get A. I'm going to confuse myself, but we got to know 2 of the 3, right? Like we're not multivariable calculus. We are a single variable. In other words, we need 1 unknown in an equation, not 2. So that's the part that really hangs students that haven't done this a lot, is you try to apply an equation where you don't have that information. Like if we didn't have 2 sides, we can't use it. We'll really like beat our head against the wall trying to use it, but we can't. We need 2 sides to use that. All right, that's good. Pythagorean theorem. You can write this in any position, right? Like you can say a squared equals c squared minus b squared, or however that algebra works, right? You can write it in any position. What else? Now we're getting to the fun ones. Right triangles and angles. I'll give you a hint. Sine, cosine, tangent. Anyone remember this? Like this is bringing flashback of memories. Yeah, we will use the inverses, but we'll just stick with the regular ones for right now. But absolutely. Inverse is just the same as the sine, just manipulated, right? So the sine of an angle is equal to what? Yeah, opposite over the hypotenuse. So there's a couple ways to remember this. Anyone remember the SOHCAHTOA is one of them? Yep. So I don't care that you have it memorized. Like, absolutely use a cheat sheet or use chapter 1 if you don't remember it. I don't care. I'm not gonna make you memorize anything because you don't have to have it memorized when you get out there. So quizzes, open book, look it up. Everything. Exams, everything. There's no reason to do a closed book anything. What was cosine? Adjacent over hypotenuse. So here's the deal. Opposite, we know what hypotenuse is, correct? It's the long side. This is right triangle and only right triangle. If it's a non-right triangle, these don't apply. Okay. So hypotenuse is obvious. It's this one. How do I know what opposite is? Absolutely. That's excellent. So students tend to not remember that or realize that. But I don't know opposite unless I know what angle I'm working with. If I'm working with angle A, what is the side opposite of A? It's that one, 44. Okay. If I'm working with the angle 28, what's the side opposite? Yes. You got to put yourself in position of whatever angle you're working with before you can determine opposite and adjacent. All right. Excellent. And what's tangent? Perfect. Again, each one of these has 3 variables, right? Angle, side, side, angle, side, side, angle, side, side. You got to know 2 of the 3 to use it, which means you can't use them all the time. Or sometimes you use them and you didn't need to use it because, like, I know this angle and I know opposite and I know adjacent. There'd be no reason to run tangent, which is opposite over adjacent. I know all 3 of those, right? So you look at what you want to know and then you apply the right function to it. We want to know angle A or C. We want to, oh, we just calculate. Did we do C yet? Oh, we didn't do C yet. Let's do angle A. What should I use? Actually, what could I use? Oh, we just did angle A. No wonder it was so quiet. Let's do side C. What could I use? I could opposite over hypotenuse, which is the sine, and it would be the sine of C, 90. That's kind of weird, sine of 90. But you could do it for sure. What else could we do? We could use this angle and use opposite over hypotenuse, right? That's sine again. So you know a lot about the triangle. You can use a lot of different tools. There's not just one. So don't overthink it. Just go, oh, okay, I'm just going to use the sine of this opposite over hypotenuse to solve for C. So I would use the 28 and not A, because A we calculated and we maybe screwed it up. So that's why I wouldn't use that. I would use the 28. That's a given. So sine 28 opposite over C. Make sense? So I do want to see this, and I encourage you to write these equations out. People make algebra mistakes a lot, and that's because they don't just quickly write it out and realize, oh, C's down below. So this is not just multiply 10 times that, right? We have to know our algebra now to figure out, how do I solve for C? So that's the other big piece, is algebra. How do I get this by itself? You remember the rules of algebra? Yep, you got to get it alone, right? All by itself, right? So getting it to the other side is one good way to do that. How do I get it to the other side? Yeah, so algebra is all about what you do to one side of the equation, you got to do to the other, right? If I have a really gnarly equation and I take the left side and multiply by 10 and the right side and multiply by 10, I have not changed the equation. That's legal. What you do to one side, you got to do the other. So if I take and multiply C times this side and C times this side, I have not changed the equation. That makes sense? What happens to this side though? Yeah, I can get rid of the C's. So now I've cleared the C out of the denominator and I have it over here, but I need it all by itself. So what do I have to do? Divide it by sine 28, right? Because this is just a number, sine 28. So that means I divide this side by sine 28. Okay, do I need to see this on your homework? No, I don't. We should have algebra by now. If I see like, oh, they're screwing up their algebra, then I might ask you to start writing your algebra out so you don't screw it up. I write mine out. Like I might not write the whole C part out, but in my head, I definitely write it out to figure out like, how do I solve this thing to get the right number? So then these cross, right? So now I'm left with my C equals 10 meters divided by sine 28 degrees. I do that right? Yeah, I think so. And now we can get a number. Get a number for me. We'll see how many of you are in radian mode and how many of you are in degree mode. Me being one of these. Interesting. Yeah, isn't that fun? We already got different numbers. Sine 28, yep. I get 21.30054468. Could be radian mode. Check your mode. Make sure it's in degree mode. So 10, I'll do it again. 28 sine. The sine of 28 is 0.469. And when you divide that into the 10, 21.30. So make sure you can get that. And then I did put the unit on it. We need the unit on for sure, always. And then the other thing to think about is your estimation of the solution. So a lot of these problems are simple in the beginning. We should be able to estimate the solution. So if I'd have drawn it a little more accurate, right? 10 and 44, that's going to be something like that. So if this is 44, is that correct? I'm not sure I like our solution. What do you all think? This is 44. Is that true? Something's wrong, isn't it? Something's crazy wrong. Hypotenuse should be what? Compared to the 44? Longer than, yeah. I did not do this intentionally. That's the fun part. The book does this intentionally. Not intentionally, the book just does this at times. Well, this is actually good. And we're coming up with what? That's what my calculator gives me. When I do the 10 sine of 28, right? Is that what we did? Yeah. Yeah. This hypotenuse needs to be what compared to the 44? Got to be larger. So something is wrong, big time. And what's wrong is this is not even, that's not a real triangle. The 28, the 10 and the 44, that doesn't match. It can't. So what I did was just threw an angle in two sides and didn't think about like, it doesn't even work with the triangle. Doesn't work. Can't. This has to be bigger than the 44. Has to be. So we have always got to estimate our solution and then go, that can't be, like, that's impossible. So if this is 44 and 10, what if I went the tangent of the angle, saying that that angle, tangent is opposite over adjacent 44, that should give me the inverse tangent of 10 over 44. Let's see what that is. $12. That's what that's supposed to be. For that to be a triangle that works, that's a 90-degree triangle, right? So bad, we had a bad angle in here. That has to be 12.80 approximately. It's really 804266. Then it works, right? So my error produced a really small angle, but then we looked at the estimation and said, that's impossible. It's got to be bigger than the 44. If we use the 1280 here, now what do we get? Ah, here, I'll calculate that too. One, 4. Much better, much better. So if you ever get a solution that doesn't make sense with an estimate, you got to stop, because the book does have mistakes in it. I'll make mistakes on the overhead. We all have to be able to look at that and go, that can't be right. We cannot just believe whatever comes out of this thing, or we will be really in trouble. All right. Have you seen that before? Sine, cosine, tangent? Yeah, might be rusty. You'll get some practice with it. You're going to do 4, 5. I don't remember. Let's do a stop share and a new share. You're going to do 2, 4, excuse me, 2, 4, and 5. And that'll be due Wednesday. And I'm pretty sure I did put up the. Yeah, here's 2. So be careful with the book. The graphic is typically below the problem. Like here's problem 1.6, and here is problem 1.6 graphic. So here is problem 1.2, and here is 1-2 graphic. So just, yeah, be careful with that. Oh, no, that's 1-3. Oh, there's 1-2. Sorry. So yeah, just look for where they've labeled the correct graphic. And what they're doing here is splitting it into a right triangle. So they have a non-right triangle, but it's split into a right triangle. So you should be good to go. Questions? All right, we have started and we are done.